Okay, this question says you are interested in investigating whether gender and major are associated at your college. The table below shows the results of a survey. So gender and major, like men, so they did a survey and this is how many men. Oops, there we go. All right, so how many men? 79 men were math science majors, 94 men were arts humanities, 72 men were business econ, other 53. And among women, 71 women were math science, 90 were arts humanities, 81 were business, 32 were other. So do men and women pick different majors? Do men tend to do more math and science and women tend to do more arts humanities, or men do more business, or what? Is there a difference? Or do men and women at college kind of tend to do, the same kind of majors, or is there a difference? Now, what kind of studies? We'll start off. What is the correct what is the correct statistical test? Well, right there it says independence. Now, would you know that if the answer wasn't staring you in the face? How do we know that? Well, let's go to the notes. Let me show you. So here are the unit 4 notes. So let me get rid of this right here. So here's the unit 4 notes. And looking at those, we see, okay, so here it is, test for independence. Tests only one sample to see if row and column variables are connected, related, associated, dependent, affect each other. Yeah, that's what we have. Do you see? And by the way, you might think, well, how do you know it's not homogeneity? It looks really, really close to homogeneity. Well, yeah, homogeneity tests to see if two different samples have the same distribution, whereas independence is one sample. Then you might go back and go. So the question is to know whether it's homogeneity or independence. Oh, by the way, and you might think, well, is goodness of fit, could it be goodness of fit? Well, no, it's not. If you look back, see, we have men and women, we have these numbers. It's not goodness of fit, because goodness of fit, either number one, you're asking if all the categories are the same. We didn't say that, right? We didn't say, look, every major is the same amount of math, science, arts, humanity. We didn't say they're all exactly the same. Everybody does this, the same amount of people do arts and humanities as math and science as business. No, no, no. We didn't say equal or same. And then the second way you do goodness of fit is if you have category percentages listed. We did not have any percentages. We just had regular numbers. So it's not goodness of fit. But you might think, yeah, it looks like homogeneity though. Two different samples, right? Or is it one sample? How do we know? Well, look close. There it is. If this is one survey, not two, not two groups, not not two samples. Yeah, I should just say not two surveys. Right? In other words, it says a survey, which means one survey. No, so they just went out and they asked people, "Hey, what major are you?" And then they just recorded their gender, male or female. Right? That's different than if they went out and they said, "Okay, let's get 100 men and ask them what their majors, and let's get 100 women, do a second survey of 100 women." That would be two different surveys. I know this is a subtle difference, and it's kind of hard to tell, but it matters, and you got to pay close attention. So it's different situation if we have two surveys, like two separate groups. If we specifically said let's go ask 100 men what major they are, then we'll ask 100 women. They didn't do it that way. They said let's just go ask, let's just stand in front of the library, and everybody that walks by, we'll just ask them, hey, what kind of major are you? And then we'll record their gender. So that's one big survey. It says a survey, one survey, not two. So it's one big survey. So we know it's a test for independence, not a homogeneity. Homogeneity means two groups are the same. We didn't do two groups. We didn't do two surveys, even though there's two groups here. Yeah, but we didn't specifically do two surveys where we just asked men and we just asked women. That would change the game. That's not what we're doing. And also you can see they use the word, another thing is helpful, associated. Okay, and that is right there. Associated. Yeah, it says it here too. Associated. So if you're testing one sample to see if the row and column rows are connected, related, associated, dependent, affect each other. That's test for independence. So there's how we know those two reasons. One survey and associated. We're seeing if they're associated. So test for independence. All right. So once we know that, what's the HO and the H1? Well, once you're on that, HO, notice HO is independent or not related, not associated, don't affect each other. So HO is independent and H1 is dependent. See it right here. H1 is dependent. Okay, got those. Come on down. Now it's time for the test statistic and the p-value, which we always get those from the calculator. How are we going to do it? Well, we're going to go, which calculator does it say to go to? So the test for independence, we're going to go online calculator, test for independence. No big surprise there. So we'll go to the online calculator. Here it is. Let's go for test for independence. Number 22, test for independence. And then that opens up. And we got a big chart and we just fill it in. So I'm going to go back to the problem and look at the numbers. There they are. See these numbers right here? These numbers. I'm just going to fill these in right in the chart exactly as they are. You can't really copy and paste because it's separate boxes on the calculator. So let's fill them in. So here we go. So I just wrote them down on a piece of paper so I can fill them in. 79, 71. 94, 90, and 72, 81, and 53, 32. There we go. All right. And then just come on down and hit calculate. I just put those numbers in there. Hit calculate. I just hit calculate. There's our chi-squared number. That x squared is called chi-squared. And our p-value, 0.1554, or like I said, around to 1.555. Let's go see it if it's right. Yeah, beautiful. There's our p-value 1.555. There's our chi-squared number. So this is the x squared. It's actually a Greek letter called chi squared. And there's our p-value. All right, it's time to compare. Our p-value is 0.1555. What was our alpha level? 0.1. And then how do these compare? If you're not sure, take it over on the side and line up the decimals, meaning decimal right over decimal. Right? And then, oh, wait, I didn't do that right, did I? It's 0.1, huh? Is that what it was? Yeah. 0.1. So line up the decimals and then fill in zeros with the rest of the blanks. So basically you're saying, how does 1,000 compare to 1,555? Well, 1,555 is bigger. So this one is on the wide side of the symbol. It's bigger. So greater. So yeah. So, all right. So then what does that mean about our conclusion? You know the saying, if the P is low, then the HO, the null must go, meaning go away, right? If P is low, the null must go. If the P is low, the null must go. Is our p-value low? No, no, no. Our p-value is greater. Our p-value is not low. It's greater. So if the P is not low, the HO must not go away, right? If the P is low, the null must go. If the P is not low, the null must not go away. So our conclusion is the null must not go. So the HO, we fail to reject, which is what it says right there. Fail to reject the null. We're going to keep the null, aren't we? Right? Because if the P is low, the null must go. But if P is not low, our P is greater, then the null must not go away. The null must not go away. We must not reject, fail to reject the null, keep the null. We're not rejecting it, we're keeping the null. So then what does that mean about our conclusion? There's a lot of options there. Well, we're keeping the null. So let's take that and run it back. Whoops, try a different color here. Let's take that up here. Keeping the null, which is this one. Oh, I forgot to write in there. Remember, every null is weak evidence. And every H1 is strong evidence. That happens every time, right? Every hypothesis test, the null is weak, the HO is weak evidence, H1 strong evidence. So where are we going? Well, we're coming up here to this guy. We're keeping the null, right? That's what it said right there. It said, keep that null, go get that HO. So weak evidence, independent. Weak evidence, independent. Let's write that down. Weak evidence, independent. Weak evidence, independent. Now, what is weak? It looks like they're using the words sufficient, insufficient. So what does weak mean? It means insufficient, right? Because if insufficient means not enough. Something is insufficient, not enough evidence. So there's not enough evidence. Insufficient. So we can get rid of these ones that say sufficient. There, so good. We're down to two. That's nice. We're down to two options. So there's now we're supposed to say independent. Oh, but they're using different words. Look, they're using not the same and related. Uh-oh. Okay. So here's where we got to be clear. Let's go back to the notes. Let me show you. So here, I've written it all out for you right here. Independent means not related, not associated, don't affect each other. Dependent means related, associated, affect each other. Let's go down and write those down right where we can see them to be really clear here. So again, independent, that's what we want. Independent. If like when your kids get older and they're independent, then they're not associated directly with you day by day. They're not connected to you day by day. They're not related. I mean, they're still your relative, but they're not related to you day by day. That's an independent. Those are other words. If two things are independent, they're separate, they're not associated, not connected, not related. And that's what we're supposed to conclude, right? We're supposed to conclude independent. That's what we said. That's what we're supposed to keep HO. This is a little tricky. Let me help you. Keep HO, come up here. HO said weak evidence, independent. Independent, separate, not connected, not associated. So come on down and say, okay. So then is it not the same or is it related? Related? No, it's supposed to be not related. Yeah, no, that's actually the right answer. The right answer is actually this one right here. Yeah. What now? Why? You're supposed to say independent. That's supposed to be not related. Yeah, but it's saying a negative. It's saying there was not enough evidence to conclude they're related, so we conclude they are not related. Does that make sense? It's a double negative. It's like if I said I did not skip class. Well, that means I was at class, right? Double negative makes positive. That's what this statement is saying. There is insufficient evidence. There's not enough evidence to conclude they're related. There was not enough evidence to conclude they're related. So we concluded they're not related. They're independent, right? That's the right answer. I know that's tricky. So one more time on the conclusion. We come down here. Our p-value is greater. Remember saying if the p is low, the null must go. If the p is not low, the null must not go. Our p-value is greater. It's not low, so the null must not go away. We fail to reject the null. We keep the null. Go back up to the null. What did the null say? Every null says weak evidence, independent. Weak evidence, independent. So we come down here and we go, okay, weak evidence, insufficient, not enough, independent. So we go, oh yeah, so it's insufficient to conclude related, right? So that means they're independent. They're not related, right? Independent is the same as not related. Two things are independent. They're separate. They're not related. And so we're saying there was not enough evidence to conclude they're related. So we concluded they are not related. And that's correct. And so I know that's tricky. You got to spend some time saying that to yourself. And there we go.